Hello everyone, this is called LLM Team Chat. I could have called it LLM Group Chat, but that might have implied that there were multiple LLMs involved. That's something to look at in the future, but for now we've got multiple users chatting with one LLM. And the replies get broadcasts to all of the clients connected. I'm showing it here with 2 clients, but you could have more than 2. We're using Python, the OpenAI API, Asyncio, Websockets. So why do you actually want to have multiple users see the responses in an LLM chat application? Here are some reasons. You want to share the knowledge across teams. You might want to have multiple perspectives. So one person asks a question, and then that prompts another person to think of an additional question. It's brainstorming. It's an evolving information repository, reduces redundant queries, saves time. So it saves 2 people asking the same question. This is a code which we'll be looking at shortly. This is 2 chat windows. Obviously, I've screenshotted this on the same computer, but it's using different ports. You could have this running across a local area network with multiple users. I've not added the code for a remote network yet, but that would also be something to add. If you like these videos, don't forget to do the subscribe and all the YouTube stuff for the algorithm, get these videos seen. And here is part of the code. And I've picked out what I think is the interesting bit. So we've got the handle client, which is async with. So that's got the context manager, which handles the sessions. We're using the WebSockets, and we're looking for @LLM here inside the yellow shape. @LLM, uppercase or lowercase, doesn't matter because we convert it to lower. If it's for the LLM, then we run the query LLM. It strips off the first 4 characters. We await that response. We await it because we're using async, it's asynchronous. So at some point we will get the response. So it's non-blocking. We await, and then we broadcast the message. So we broadcast it back to all connected clients. And you can see over here on the right, 4 client in list of clients. So that's where we send it to with every client that's in the clients list. Just above it, note we've got clients, we're using lock. Lock is how you avoid data races, so you don't have multiple things trying to write data at the same time and you get in a mess. So this is LLM Team Chat. I'll just quickly show you the very basic diagram of what's going on. So user 1 talks to the server, and then server, if it's got @LLM in the message, sends it to the LLM. LLM actually replies to user 1 and user 2. They both see the reply. If user 1 and user 2 just want to talk amongst themselves, then that's fine. They just don't put @LLM in the start of the message. Note here in red, I've put, this is a to-do. So again, you could actually, if you wanted, you didn't even want to involve an LLM or send any data off site, you could actually have an MCP server, which was doing the functions and providing the tools, the resources, and the prompts that you want. But this example is actually sending data up to OpenAI's API with the chat completions. If you wanted to use another provider, you could just tweak the code slightly. So we've looked at the overview. Let's look at the code. Okay, so this is the structure of the project. I've got an MCP server waiting in the background, which will be included in due course. So the main 2 components are the server and the front end. The client.py was a CLI that I used for testing. So index and server. To run it, Python, I've got Python 3. Let's do Python 3.12 and then source 37 and then server.py. And that's because I should be using Python 3.10. Right, that's running. This issue here was just because I've got multiple Python versions on my machine. If you've only got one Python version, or if you've got them all up to date with the same packages, then you wouldn't see that error. It's just that I hadn't installed WebSockets for 3.12, but I had installed WebSockets 3.10. Okay, right, let's test it. So bring up a new window. And I'm just going to do Firefox just to fire up the chat page. That's my first one. And let's bring up a second one. What I'll do is I'll do duplicate tab. So if we, just to show you, in a minute you'll see different hosts connected. So if we do user 1, hi, you can see sending message. It knows that we've got two clients connected. We've got one connected on port 34460 and one on 499 and 42. So that was user 1. If we go to user 2, you see how user 2, we'll just call that user 2. So user 1, user 2. So if we go to user 2 and we say hello, you see on user 1 it's updated now as well. Perhaps if I drag this to be a separate window, it will be a bit more visually obvious. You see how we've got user 1 and user 2. Okay, so now if we do @LLM, and then we say, what is the area of the UK? And you see, user 2, user 1, both updated. And they're on different ports, but the same IP address range. So they're running on a local network. I'd need to add a bit more, a lot more code to make it work over a remote network. We'd need to add probably SSH or some such, depending if one is secure, if one is made public. But there we go. That's what's going on behind the scenes. Everything you see in the GUI is what you see here. So what we've done is we've used Asyncio and Websockets to broadcast the LLM response. Now, the LLM only gets used if it's required or if it's called. So if we look at the code and we go to source and we look at server, you see the conditional logic here. If text.lower, so if somebody puts in capital or lowercase, it still gets converted, it still appears as @LLM. So if you put in @LLM in, await broadcast. So log and broadcast the user's question, thus making it appear on the server output. This is what's actually querying the LLM, await query LLM. And the text for strip is just stripping off the @LLM from the question, because the LLM doesn't need to see that. So I've used OpenAI, import OpenAI. You could easily modify this to work with an other LLM provider. The next step would actually be to include different LLMs in the chat. So rather than having @LLM, you would probably call it @OpenAI LLM, or you might even give it a name, or you'd just call it Claude if it was Claude. And then you have the option of involving multiple LLMs in a chat, as well as multiple humans. This user 1, user 2, anonymous, this is a toy example. So you'd obviously put in some user, you'd have a request for the user to enter their name, their details, their authentication, and so on. If we do, just to show the lowercase, uppercase thing, at LLM, and what if it's in the middle of a sentence? Hey, why is glass transparent? And we've broken it because it only needs it at the start. So we could modify that if you wanted. You might not want to. The important things to look at here is the async-io and the WebSockets. Whenever you do something with async-io that may, if it's IO bound, so if it's going to use the network, for instance, a network, and it's making a request, a remote request, then you need to prefix it with await, like we do here, await broadcast, await query, await broadcast. Broadcast is a function that I've written. So for client in the clients list, await client send, so send the message to the client's remote address, and because it may or may not take some time, then we need to await. It takes a bit of practice getting to know where to use await. This is very standard query. We're using client.chat.completions.create. If you look at the OpenAI API documentation, there are variations on this. I'm using ChatGPT 3.5 Turbo because reasons. And here you just need to have your main event loop, which is if name equals main, async-io.run, and then main, where main is what we've written here. So await WebSockets.serve, and then you pass in the handle client, the client handler, host port, ping interval. I think that's new. One of these things was a bit of an optional thing. And then you're just waiting for the server to be closed. So basically run until someone does Control+C. I've chosen a random port to run this on. You can modify that to suit. The lock it ensures global set to track connected clients and a lock for thread safety. So you don't get data race, you don't get multiple people trying to. So here, within your client handler, with clients lock, so this is like a context handler. So it looks after the session, the cleanup. You do this, but as you see, you then have async inside it. So with the context, you have the context first, and then you actually do your main async tasks inside that. You use try, and then accept down here, decode error there, or that's with the async, and then you actually have exception, and then finally is basically cleaning up and removing the WebSocket. So, as I say, this is work in progress. This is an experimental toy example to just familiarize myself with async and WebSockets, but it's usable and it's got lots of potential because you could add other LLMs, you could make this work remotely, and also you could add on an MCP server, so the two humans could ask a question and the LLM would then just hand that question back to an MCP server without going over the internet, without leaking data. So, okay, so you probably want to see the index HTML as well. This was done with the help of ChatGPT. We've got the CSS link href is using Bootstrap, which I asked it to do. I asked it with a prompt to create a modern theme. We've got a container. Then after the footer, we've got the script, which is constant for the WebSocket server, which is a new instance of the WebSocket. WS rather than HTTP. Localhost and then port number. You can specify whatever port you want, just make sure it matches what you've put in your Python code. Chat box, user input, send button. These are all constants, so and then you can, it saves you having to type document get element by ID, chat box, etc. So to display incoming messages, we want to add a new div, which will be of the class LLM or class user. We put in the time, new date, local time. So we have the time next to the message in the message history. And then this is what does most of the work, which is we listen for a click, which was from the send message to LLM button, which then passes the JSON stringified version of the input text question. And then we receive the past event data, which comes back, and then send message in it. That's just sending the message. So that's what's receiving it and passing it. And yeah, your best bet is to try this, I would say, rather than messing around with Gladio or Streamlit or anything like that, because this is very straightforward, really. Ask ChatGPT, tweak it. You've got a bit of JavaScript at the end, which, to be honest, ChatGPT or the Claude or whatever, Gemini, they're so good at HTML and JavaScript. If you're trying to write backend, why waste time or spend too much time worrying about this side of things? So yeah, there we go. That's the front-end GUI. All this code's on GitHub if you want it. Async-chat-llm, RGGH. And there we go. Have fun.